Hi there. Here's a little extra help to get you through your average atomic mass worksheet. Question 3, question 4, and question 5 and 6 are all similar problems to this example here. First of all, we want to find out how abundant the isotopes are. So what we're going to do is we're going to set up our equation first. So I wrote down our equation. It's in your flip chart. It's also from our lab that we did, which is on Moodle 2. We have our average atomic mass. That is what we find on the periodic table. That's equal to the mass of our isotope number 1, our first isotope. In this case, for gallium, this isotope mass here is 68.93. And then we're going to multiply that by its percent abundance. But we don't know what that is. We're going to solve for that. So I'll come back and fill that in just a bit. Then our second isotope's mass here is 70.93. And then we'll figure out what our percent abundance is there. We divide all of this by 100, and it's equal to our average atomic mass, which is 69.72, which also can be found on the periodic table. So we want to solve for our percent abundances. Our percent abundances both add up to 100. So what I'm going to do is I'm going to plug in 1% abundance as x, and then the other one will be 100 minus x. So both of these should add up to 100. Then we're going to do some math, some calculations. Usually what I find most helpful is to cross multiply each side by 100 to get rid of the fraction. And so that will give us 6,972 on our left-hand side, and I'm going to factor in our x's here, so we have 68.93x plus, and then I'll take this number and I'll multiply it by 100, and then I'll take that 70.93 and I'll multiply it by x. So we'll have 7,093 minus 70.93x. Now, taking my calculator, I'm going to get the x's on one side and the numbers without an x on another side. And so I'm going to subtract 7,093 from 6,972. So I'm going to do minus 7093 from both sides. And then what that leaves me over here is negative 121. And this will equal, and after we combine this number and this number, we'll have negative 2x. To solve for x is equal to 60.5%. That means that our isotope 1, which is this one, shows up 60.5% of the time. So that's what this value is equal to. Now we can subtract this from 100 to figure out what our second isotope abundance is equal to, and that is 39.5. So for these problems, you'll have two answers, and they should add up to 100. Good luck.